Now let's deal with the electric lines of force. Now as you can see, the electric lines of force are imaginary lines drawn in such a way that the direction at any point of the tangent is the same as the direction of the field at the same point. And I will say that the closer the lines of force, the stronger the electric field in that region. So for a point charge, the electric field decreases as 1 over r squared. This means that the electric field is 4 times less at the larger sphere than the smaller sphere. That is all for electric field. Let's go on to the properties now. And the properties of the line of force, the line of force are drawn such that the magnitude of the electric field is proportional to the number of lines crossing a unit area perpendicular to the lines. The lines of force are continuous and they start on positive and end only on the negative charges. The tangent to the lines of force at every point gives the direction of the field. The lines of point do not touch or intersect one another. This is what you need to know about lines of force. Usually comes out in tests. Now let's just go straight into the Coulomb's law. The Coulomb's law. Sorry for the blur, this symbol already for you. The Coulomb's law states that the force between 2 point charges is directly proportional to the product of the charge and inversely proportional to the square distance r between them. As you can see, F is proportional to Q1, Q2 over r squared. And we have our K, which is the constant of proportionality, and is equal to 9 times 10 to the power 9 Newton meter square per Coulomb square. And we have our E naught, permittivity of free space, has its own value. This all is known, and then can zoom in. Now let's solve questions. Now question 1 said find the force of attraction between the negative 3 microcoulomb and 4 microcoulomb charges with a distance of 2 meters between them. Now let's solve now. As you can see, the question is pretty simple. You just say we should find the force of attraction between the minus 3 microcoulomb and then we also have the 4 microcoulomb charges with a distance 2 meters between them. Now from what you see what Coulomb's law is, now let's solve it now. So we have the solution. Alright, now in solving physics questions, especially for your tests, do not forget the first thing you need to do is to write down your parameters, because in Futo physics department they love when students write the parameters down first and things like that. So the first thing to do is write down your parameters. Now what are the things given to us? Now we have the first charge, right? That is our Q1 equals to negative 3 microcoulomb. Now I have told you, they said define the force of attraction, right? Obviously that means the force will be a negative force. Okay, so now the negative is not really important. You just show that this first charge is opposite of the second charge, right? Now changing this micro into the normal coulomb, because microcoulombs is not the SI unit of charge, right? So this will give us negative 3. What is micro? Micro is just times 10 raised to power minus 6 coulomb. So this is all right. This is an SI unit, you understand? So the second charge was given to us, and the second charge is what? 4 microcoulomb, and that will be what? 4. What is micro? Times 10 raised to power minus 6 coulomb. You get? Now we know our distance r is already in meter, so that is just 2 meters. All right. And then we already know our constant k, which is 1 over 4 pi times the permittivity of free space, and that is equal to 9 times 10 raised to the power 9 Newton meter squared per Coulomb squared. Now what is Coulomb's law? Now Coulomb's law is equals to k times Q1 times Q2 divided by what? R squared. This is Coulomb's law. Am I right? So our first now equals to our K is 9 times 10 raised to the power 9, then times what is our Q1? Our Q1 is negative 3 times 10 raised to the power minus 6 multiplied by what is our Q2? Our Q2 is 4 times 10 raised to the power negative 6, all divided by what's our R2 squared. Do not forget that. And if you do that, you can just punch your calculator, alright, because in physics. And now when punching your calculator, probably I have a video where we'll learn how to punch a calculator. So in the video where I'm solving plenty questions, we also learn how to punch our calculator. Also very important, make use of brackets and things like that. You get? So now So when multiplying this thing 10 by 10, make use of brackets. If you're punching your calculator, this should be in brackets, or this should be in brackets, or this should be in brackets, and this also should also be in brackets. You understand? So when you punch the first one, which will be in brackets, should be having 0.108 negative. All right, so divide by, what is 2 squared? 2 squared give me 4, and if you divide this, that should give you negative 0.027 Newton. But since the negative, just to show you that it's a force of attraction, you can get rid of the negative and just write force is equals to what? 0.027 Newton, and there you have it. So this is how to basically solve the question on Coulomb's law. You get, so please learn this. You know, the first thing to do is check whether everything is in SI units. Please do not make mistake. In physics department in Futo, they always check whether you put all your quantities in their perfect SI units. So please make sure everything is in their standard units. You understand? So this will be all for now. Please remember to like and subscribe. Bye for now. See you in the next video.